funky one with a loop inside. So for this one, for this example, it's our example 2, because that's as far as we're going to get. We got r equals to 1 plus 2 sine of theta, and I know it's got an inner loop because I understand these. You're going to set up, don't integrate, this problem. So the area I want to find is I want to find inside the inner loop. That's the easy one. Part B, I want you to find the area between the loops. So I want between the inner and outer loops. That's hard, and I will show you why. It's hard conceptually. Okay, to do this one, first off, let's take that r and let's figure out what points we want to graph. It's still sine, so my favorite angles are the same ones. 0, pi over 6, pi over 2, 5 pi over 6, etc., right? I want the pi over 6s. So we set it up. We have angle. We have radius. We want 0, pi over 6, pi over 2, 5 pi over 6, pi. Then we want 7 pi over 6, 3 pi over 2, 11 pi over 6, and 2 pi. When I plug those in, sine of 0 is 0, so I just end up with 1. When I put in pi over 6, I get a half of 2 is 1, 1 plus 1 is 2. I move pi over 2. Sine of pi over 2 is 1, 1 times 2 is 2, plus 1 is 3. 5 pi over 6 is the same value as pi over 6, pi is the same as 0. Then there's 7 pi over 6. That's a negative a half. Times 2 is negative 1. It goes to 0. Uh-oh. Then we put in 3 pi over 2. That's a negative 1. That means it's negative 2 plus 1 is negative 1. I have looped back. That's the inner loop. Then at 11 pi over 6 is back to 0 again. At 2 pi I get back to the 1. And I close it. This is the inner loop. This right here. That's the inner loop. So if I'm going to find the area of the inner loop, do I just need to integrate from 7 pi over 6 to 11 pi over 6? Yeah. But let me draw it for you so you believe me. You ready? Here we go. We're going to draw. My max value is 3, so 1, 2, 3 should be sufficiently large. 1, 2, 1, 2, 1. Okay, here we go. So starting at 0, my value is 1. And then at pi over 6, it's 2, so I'm going to swing out about 30 degrees. That's close enough. At pi over 2, it's 3. At 5 pi over 2, it's back to the 2, swing it out, make it about right, make it somewhat symmetrical. And then I get back to pi at 1. Between pi and 7 pi over 6, it goes to 0. Then from 7 pi over 6 to 3 pi over 2, it goes to 1. And then when I go to 11 pi over 6, it comes back. And then it goes back here. Now, everybody got your dots. Now I want you to watch me graph it. Watch. So I'm going to start here at 0. I am going to swing around. I'm going to come down to pi. That was all straightforward. Then this loop comes around, gets here, there. That is to where I get to the 3 pi over 2, because it's negative 1. Come back down here and close it. So this was 0, pi over 6, pi over 2, 5 pi over 6, pi. Went to 0 at 7 pi over 6, went up at 3 pi over 2, came back at 11 pi over 6, and then closed it at 2 pi. Very cool, right? Now do you see why? Because I got to 0 at 7 pi over 6. Then I went up and around. So when I'm tracing this, is that between 7 pi over 6 and 11 pi over 6? So if I'm integrating, am I gonna take my windshield wiper as I go from 7 pi over 6 to 11 pi over 6? Did I highlight the inner loop?
Yeah.
I'm going to use that more than once. Here we go. So for part A, where I want the inner loop, the area is equal to 1/2 integral 7 pi over 6 to 11 pi over 6 of my lemniscon, which is 1 plus 2 sine of theta d theta.
Is it squared?
It is squared. And squared. Right? That's the easy one. Now let's think about the other one. I just want to show you, when I integrate the whole thing, watch what happens. I start at 0. I am going to integrate that. Am I finding the area with the loop? As long as, and I am still going to pi. Did I just find all of that area above the x-axis? Yep. And then if I keep going from pi to 7 pi over 6, do I get this sliver? And then if I go from 7 pi over 6, do I highlight the loop a second time?
Oh.
And then from 11 pi over 6 to 0 to 2 pi, do I get that last bottom piece? The problem is, if you integrate from 0 to 2 pi of one of these ones with an inner loop, will you get the loop twice? If you wish to do that, that's fine. Just subtract the loop twice afterwards. You found the loop in part A, didn't you? So one strategy is just integrate from 0 to 2 pi, the whole thing, and subtract out the loop twice.
Couldn't you integrate from?
I just said that was one way.
Not.
But the next way, the way I prefer to do it, I don't want to do that. I would much prefer not to have to cover everything. What were you going to suggest?
Oh, I was gonna say cutting it in half.
Yeah, there is cutting in half. I like cutting in half. And the best part is, if you integrate this half, not that half, because I don't want to come from 3 pi over 2. That would have to be a negative angle, and I don't want to go there with y'all for some reason. If I just come from pi over 2 and I sweep around, can I get to here? So if I go, so I'm going to show you a different color. Let's do this. If I go from pi over 2 all the way to 7 pi over 6, have I got all of that half of it, including the loop? And then do I just have to subtract out a half of the loop? Right? Is that simple? And I can go from pi over 2 to 7 pi over 6, and then I can subtract from 7 pi over 6 I can subtract out this half of the loop. I don't have to subtract out the same half. I can go from 7 pi over 6 to 3 pi over 2, or I can go from 3 pi over 2 to 11 pi over 6. It doesn't matter. Whichever one you want to do.
Why do you choose that?
Huh?
Why do you choose that half of the shape?
Because that way I don't have to deal with my whole negative. Okay, the first choice is integrate from 0 to 2 pi and subtract out the loop twice. I'm saying if you don't want to do that, I don't want to deal with that. I want to be a little cleverer. I'm going to do this half, and I'm going to go from pi over 2 all the way to 7 pi over 6 and get the whole half, and then I just have to subtract out half the loop. So my area for part B is going to equal to, I'm doubling it, right? So it's 2 of 1/2 the integral from pi over 2 to 7 pi over 6 of 1 plus 2 sine of theta squared d theta minus, and I'm going to do 1/2 integral, and you can do it any way you want, but I'm going to do the 7 pi over 6 because I just feel like continuing. 7 pi over 6 to 3 pi over 2 of, and so this is the inner loop. What's half of it? You can do it that way, or you can just integrate the whole darn thing. You're going to do 1/2 integral from 0 to 2 pi of 1 plus 2 sine of theta squared d theta, and I'm going to subtract out 2 of what I found up above, which is the 1/2 integral of 7 pi over 6 to 11 pi over 6 of 1 plus 2 sine of theta squared d theta. Either one will work. Just how do you want to choose your poison? I don't care. I just want you to know multiple ways. Why would I want you to know multiple ways? Because I never am sure what they're going to ask on the AP test. And although they have been, Polar went away for years, nobody was teaching it but me. And then Polar came back, and so far it's been really easy questions. But in college, they will ask something where they will force you to have to know that. If you actually have to take it in college, yes. Hang on, I'm going to stop recording.